Good morning. In this video, we will see about the linked list implementation. What is linked list? Linked list is nothing but the connection of series of nodes. In linked list, the data are not stored in the adjacent memory. It contains the element and a pointer to node containing its successor. It is used to avoid the linear cost of insertion and deletion. We have two types of linked list. One is singly linked list and another one is doubly linked list. In singly linked list, we will have two portions. One is data part and another one is address part, which is pointing the next data address. See, in this PPT we can see that the first node contains the starting pointer value and the last node contains the null pointer value, which means that the end node is not pointed to any other node or data point, which tells that it is the end of the linked list. Doubly linked list. In doubly linked list, we can see two part. One is next pointer and previous pointer. Data part contain the value which is stored in the data, and in next part the address of next data is stored in the next pointer and address of previous node is stored in the previous pointer. And as usual, starting pointer and end pointer is also present in the doubly linked list. See, in singly linked list, we can see that data 2 is present in 2003 address and 2004 is the address pointer which points to the data part 4. The address of data part 4 is stored in 2004. But see, we can see that 4 is present in 2184, address 2184. That address is given in the address pointer of 2004. This is the simple example of singly linked list implementation. We can similarly we can see that address of 6, which is 3225, is given in 2185, and address of 7 5571, which is given in address part of 6, which is 3226. This is the simple example of singly linked list. Okay, in singly linked list we can perform two operations. One is addition and deletion. Addition is nothing but inserting an node in singly linked list. Inserting a new node before head is very easy, and inserting a node at end is also very easy. And there is another case which we have to insert a node in the middle of the linked list, which is a little bit challenging. Okay, consider if we have an empty list which indicates that head is equal to null. There is no any data in the list. We can represent it as head is equal to null. Then the insertion is very easy. The algorithm sets for both head and tail to point the new node. If there is no any element in the linked list, then the insertion and deletion insertion in the beginning or end will be very easy. See, before insertion there is no data point and there is no pointer here. After insertion we can see that there is a new node which has a data point and a pointer there. Okay, add first. In this case, new node is inserted right before the current head node. We can consider a linked list which consists of 5, -1, 16 and 2. Here, first node in the linked list we always used to call as head, and last node we always used to call as tail. How to identify that first node and last node is nothing. If we have if it is the first node in the linked list, we can say that as head node, and if that node does not contain any address point, then we called it as tail node. Okay, if here we want to insert a new node in the beginning, just we want to point the address of head node to the new node. If we point that address of head node to new node and name that new node as head, then the insertion of a node in the beginning is very simple. We have inserted the node to the linked list and named that new node as head. See, it is given here. Only two steps we have to follow. First one is update the next link of the new node to the pointer to current head node. We have say for example, address of head node is like 2000. What we have to do is, in new node we have to link the address of the head node and name that new node to a head node. That is the simple point we want to do here to add or insert a new node in the beginning. See, these are the steps we have to do to insert a node at the beginning. Okay, and another scenario that is also simple one, we have to insert a node at the end. Nothing but we have to insert a node or connect or link a node in the tail part. It can be done in two steps. Update the next link of the current tail node to point the new node, and update tail link to point the new node. See, here 2 is given in the tail node. What we have to do is, we have to just give the address of the new node to the tail pointer and name the new node as tail. That's all. The insertion of a node at the end is also done, which is very simple. See, general case, in general case, a new node is always inserted between two nodes which are already in the list. Head and tail links are not updated in this case. We need to know two nodes, previous and next node, between which we want to insert the new node. This can also be done in two steps. Update link of previous node to point to the new node. Update link of new node to point to the next node. This is nothing but inserting a node in between the linked list. For that, we want to know where we want to insert a new node. It can be, see, in the given scenario we can see that new node has to be inserted in between -1 and 16. For that, what we have to do is, we have to remove the pointer of -1, address of -1, where the address of -1 the address of 16th node is already stored. Now what we want to do is, we want to cancel that link and insert a new node in between and give the address of that new node in -1, and